Hello everyone, welcome to our math session. Before we start, please be ready with your learning materials for the week and have with you your paper and a pen for the activity. So, fasten your seatbelt, just relax, and enjoy learning.
I'ma cook it up like this.
And to start with, let us try to remember what is in our past lesson. Okay, so we have here a right triangle has one right angle and two acute angles. Opposite the right angle is the hypotenuse, which is the longest side of the right triangle. And a mnemonic device for remembering the definition of the primary trigonometric ratios is we have SO, KA, TUWA. Where SO is the acronym for the sine, which is equal to the opposite over hypotenuse. KA stands for the cosine with equal to adjacent over hypotenuse. And TOWA is tangent, which is equal to the opposite over adjacent. So as you can see in the figure there, you have there the trigonometric ratios, sine, cosine, the tangent. We have here the cosecant and cotangent. There are 6 trigonometric ratios. 3 of these are called the primary trigonometric ratios, while the other 3 are secondary trigonometric ratios. The primary trigonometric ratios are the sine, cosine, and tangent, as you can see here below. So the sine, cosine, and tangent. While the secondary trigonometric ratios, you have here the cosecant, secant, and cotangent. Somebody says, hey, let's take a look. How will we apply trigonometric ratios in solving right triangle? That could be a question. And he said, teach me please. Let's find it out. That's why today, we have quarter 4, week 2, module 2. We'll be discussing solving right triangles using trigonometric ratios. This would be for the grade 9 level. Solving a right triangle means finding the measure of the remaining parts. On your previous lesson, you have learned how to solve one side of a triangle given two sides using the Pythagorean Theorem. This time, you will learn new concept in solving parts of a right triangle. Just remember the 6 trigonometric ratios: the sine, cosine, tangent, cosecant, secant, and cotangent. In this section, you are going to apply your knowledge on trigonometric ratios in solving right triangle. And there are different cases that we have to consider. Like for example, let's have the first case. Solving a right triangle given the measure of the 2 parts. And what are these 2 parts? The length of the hypotenuse and the length of one leg. Let's take a look with this first example. Triangle ABC is a right triangle at C. If side C is equal to 25 and side A is equal to 19, find angle A, angle B, and side B. Express your answers in 2 decimal places. So in this case, you are going to illustrate first the figure. So we have here our figure on the screen. As you can see, we have here side C and side A. So to solve for the measure of angle A and angle B, including side B, so we have to remember the SO, KA, TOWA mnemonic device. In that case, if we're going to solve for the measure of angle B, we would have side A is the adjacent side of angle B. C is the hypotenuse of the right triangle ABC. That's why using ka or cosine is equal to adjacent over hypotenuse, so you could use A over C, where our side A is equal to 19 and side B is equal to 25. As we simplify, that would be 0.76. And of course, using your scientific calculator, you would have inverse cosine. To find the measure of angle B, you would have 40.54 degrees. So that would gonna be the measure of angle B. Now, how about if we will find the measure of angle A? So from the illustration, you have it there. Since in part A, you have solved angle B is equal to 40.54 degrees, then we can conclude therefore that angle A and angle B are complementary angles. Or you could have, since they are complementary angles, it measures 90 degrees. So that's why, in our solution, angle A is equal to 90 degrees minus 40.54 degrees. So the total will gonna be 49.46 degrees. And that would be the measure of angle A. And to solve for the side B, you would have to use the Pythagorean Theorem. What is in the Pythagorean Theorem? You have here, A squared plus B squared is equal to C squared. So our A there is 19, our B is unknown, and our C is 25. So by substitution, you would have 361 plus B squared is equal to 625. Looking for the value of our B, you would have 625 minus 361 as we transfer 361 to the other side. And you would have 264. Then take the square root of 264 since we're looking for the value of our B alone. By the way, in that case, that is only B, not B squared. So the answer we're gonna be 16.25. That would be our side B. Is that clear? Again, the B there, that's not B squared. That is B is equal to 16.25. Now let us now have the second case. What is in the second case? Solving a right triangle given the length of the hypotenuse and the measure of one acute angle. Let's take a look with our example. Triangle ABC is a right angled at C. If side C is equal to 30 and angle B is equal to 55 degrees, find angle A, side B, and side A. In that case, always have with us your illustration. So that's why we have here our illustration that side C is the hypotenuse, which is 30, and angle B is equal to 55 degrees. And we're looking for the measure of angle A, side B, and side A. Now, in solving this problem, take a look with angle B and angle A. They are complementary angles. So therefore, to solve for angle A, since angle A and angle B are complementary angles, then you would have angle A plus angle B is equal to 90 degrees. And we are going to substitute the value of our measure, the measure of angle B, which is 55. Then you would have 90 minus 55 is equal to 35 degrees. That would be the measure of our angle A. Next step, to find A, since A is the adjacent to angle B, and C is the hypotenuse, then you can use ka, or the cosine. That's why we have here in our solution, cosine theta is equal to adjacent over hypotenuse. What is our adjacent there in our illustration? That would be considered as our side A over side C. So as we substitute, you would have cosine 55 degrees is equal to A over 30. So since we're looking for the value of our A or the side A, you would have, using cross multiplication, you will therefore have 30 times cosine 55 degrees. And that would give you, cosine 55 degrees is 0.5736. Multiplied by 30, you would have 17.21. And that would be the side A, 17.21. And solving for side B, since B is the opposite side of angle B and C is the hypotenuse, then in that way we can use SO or the sine equals opposite over hypotenuse. So right there, sine theta is equal to opposite over hypotenuse. As we substitute B over C, that would be sine 55 degrees is equal to B over 30. Cross multiplication, you would have therefore B is equal to 30 times sine 55 degrees. By simplifying, you would have side B is equal to 24.58. So that would be then our length of side B. You got it? Alright. Now let's proceed with the third case. What's in the third case? Solving a right triangle given the length of one leg and the measure of one acute angle. How does it look like? Let's take a look with our example. Okay, so we have here the third example. Triangle ABC is a right angled at C. If angle A is equal to 60 degrees, and angle A, side A rather, equals 17 inches, we are going to find angle B, side B, and side C. Again, we have to illustrate how does it look like. Or simply, we have to label those given. So from the illustration, you have here, angle A is 60, and side A is equal to 17. Looking for the measure of angle B, side B, and our side C. Same pattern. So solving for measure of angle B, you would have to apply complementary angles. Are they right? So you would have angle A plus angle B is equal to 90 degrees. You would have, therefore, 90 minus 60. In that case, this angle here is equal to 30 degrees. Okay? So next up, to solve for side B, since B is the adjacent, okay, this side is adjacent side to adjacent side, and A is opposite to the angle A, this one, then you can use TOA, or tangent is equal to opposite over adjacent. So therefore, you would have tangent theta is equal to opposite over adjacent, which is represented by A over B. By substitution, tangent 60 degrees is equal to 17 over B. By cross multiplication, therefore you would have B times tangent 60 is equal to 17. So divide both sides by tangent 60, or you could have as an equivalent of 1.7321. You would have therefore 9.81 inches. So that would be the side B. So for side C, you would have to find the value of C, since side C is the hypotenuse and side A is the opposite side of angle A, then you can use SO, or sine theta equals opposite over hypotenuse. So as we substitute, sine A is equal to A over C. Or you could have sine 60 degrees is equal to 17 over C. So by simplifying, therefore you would have the side C is equal to 19.63 inches. So we have here a tip. Let's click this one. It says, try it using the Pythagorean Theorem to solve for the value of C. Check if you get the same answer. Okay? So that will be yours. Now, okay, let us now proceed with letter C. Alright, you have it there already. Solving a triangle given the length of two legs. Like for example here. Okay, so triangle ABC is a right angled at C if side A is equal to 15.5 inches and side B is equal to 10.8 inches. We are asked to find the measure of angle B, angle A, and side C. As you look into our illustration here. Okay, so if this would gonna be the case, we would have letter A. To find C, or side C, you may use the Pythagorean Theorem. Alright, so it says there that C squared is equal to A squared plus B squared. So in that illustration, in our problem here, the side A is 15.5 and side B is 10.8. So we just simply have to substitute to our given formula. So as we substitute, C squared is equal to 15.5 square plus 10.8 square. And simplify, you would have therefore the length of our C is 89 rather. So that will gonna be our side C. Now, it's already been there in our screen to solve for angle A. Since that side A and side B are opposite and adjacent side of angle A respectively. Then in that case, you can use TOA, or shall we say, tangent is equal to opposite over adjacent. So, as we are going to take a look with our illustration, this would be the side, the angle A. So, angle A, or tangent theta, opposite is 15.5 and adjacent is 10.8. So as we substitute, you would have there tangent A is equal to 15.5 over 10.8. So you can get, as we simplify, that would be 1.4352. Since you'll be using your calculator, you would have angle A therefore is 55.13 degrees. Okay? So you'll be only looking for your angle A. Is that clear now? So let's now proceed. So as you have noticed in our illustration, so angle A is 15.13 degrees and side C is 18.89 degrees. And we will be looking for the measure of angle B here. So, to find the measure of angle B, you would have angle A and angle B are complementary angles. Remember that one. Then the measure of angle B therefore can be solved like this. Angle A plus measure of angle B is equal to 90 degrees. So we're looking for the measure of angle B, so you would have 90 minus 55.13 degrees, which is the measure of angle A. And that would give you therefore 34.87 degrees. Okay, I think that was very clear. Okay. So, oops. Got satisfied? Oh, he got a question. Well, more please. Oh, it says here. Okay, let's have this more examples. Okay, let's take a look with the directions. Find the measure of each indicated angle or side on the right triangle. And you are asked, or we are asked here, to express our answers into decimal places. Okay, let's have number 1. You have it here in the screen. Okay, so we will have this problem here. So we are looking for the length of our x, the measure of angle y, and so with the measure of angle t, which is represented by that theta. Okay, this is very easy. You'll just simply have to know again the different trigonometric ratios. So to solve for this, you would have, let's say for example, letter A. Let us solve for x. So to solve for x, you will be using Pythagorean Theorem since the two sides are given. So we'll be use Pythagorean. Okay, so it says in the Pythagorean Theorem that you would have c square is equal to a square plus b square. So our hypotenuse here is 15 and these are the sides. So we could have 15 square is equal to x square plus 12 square. What is 15 square? That is 225 equals x square plus 144, and we're looking for the value of our x square, so we have to transfer 144 on the other side. So as we transferred 144 on the other side, you would have x square is equal to 225 minus 144. And this will give you 81. So x square is equal to 81. But we are not going to end up there. But instead, we have to take the square root of x square and 81. So you would have x is equal to 9. So the value of our x is 9. So this side here is 9. Now let's proceed to the second solution. We will be looking for the value of, the measure of angle t, which is represented by our angle theta. So to solve for the measure of angle t or the theta, we will be using, you will use what? That is adjacent over hypotenuse. So we'll be using ka. Okay, so the cos theta is equal to adjacent over hypotenuse. So our cos here, cosine theta, therefore is equal, our adjacent is 12. So 12 over the hypotenuse, which is 15. So you would have it there. So cosine theta is equal to 12 over 15. So as we divide, this would be cosine theta is equal to 0.8. Or to find the measure of the angle, cosine theta is equal to the inverse of cosine. You would have 0.8. So therefore, you would have 36.8699. That would be our theta. Okay, so you could also have, or you would have theta is equal to 36.87 since we are all asked to have a 2 decimal places. Okay, so that would be our theta. Okay, so next up, we will solve for the measure of angle r, which is represented by y. So to solve for measure of angle r or y, we'll be use saw. Okay, so that means sine y is equal to opposite over hypotenuse. So from the figure, going back to the figure, so we're looking for the measure of angle y. So you would have opposite of it is 12, and you have here the hypotenuse. So that's why you have sine y is equal to opposite, which is 12 over 15 as the hypotenuse. Okay, so therefore you would have to substitute rather. Opposite is 12 over 15. Okay, so we know already what is the value of 12 divided by 15. So you would have sine y equals 0.8. Yung inverse sine. Okay, 0.8. Therefore, you would have 53.1301. That's our y. Or we could have 53.13 in two decimal places. That's the measure of angle y. Is that clear now? So, is there any other questions? Okay, so if there is no other question, then let's proceed. Okay, let's now have number 2 on the screen. Okay, let us now proceed with number 2. Still, we will be looking for the length of x or side x and the measure of angle y. Okay, and so with also the angle theta. So this is gonna be the same as with problem number 1. So to start with, let's have solve for x. Okay, in solving for x, as you can see, the hypotenuse is given as 9 and one of the side length is 6. So we can use Pythagorean Theorem here. So use Pythagorean Theorem. So once again, it says from the theorem that c square is equal to a square plus b square. Suppose this would be our, since this one is our hypotenuse, so that would be 9 square is equal to, let's say this would be our a, so x square plus 6, which is our b, so 6 square. So by simplifying, this would be 9 times 9 is equal to 81 is equal to x square plus 36. So looking for the value of our x square, you would have therefore x square is equal to 81 minus 36. So simplifying, you would have 81 minus 36. This would be equal to 45. So x square. So we're looking for the value of our x alone. So take the square root. So you would have x is equal to square root of 45. But still, we can simplify that one. By what number? Okay, so you would have therefore, that is 9 times 5. 9 is a perfect square. So you would have square root of 9, that is 3, square root of 5. So x is equal to 3 square root of 5. Or we could have similar to 6.71. So meaning to say, the length of this side is equal to 3 square root of 5 or 6.71. Okay, so let's now proceed with solving for the length or the measure of our theta. Okay, so this angle here. So we will find the measure of this angle theta. So to find the measure of angle theta, so we will be solve for measure of angle O or theta. Okay, so we'll be using sine or so from the given, you would have theta opposite over the hypotenuse. So since these are the two which are given, so that's why we'll be using sine opposite over hypotenuse. So to solve for that one, so sine theta is equal to, what is our opposite here? So that is 9. So that would 6 rather. So 6 over 9. So by simplifying, you would have sine theta is equal to, what is 6 divided by 9? That could be 0.6666. So we'll just make use of 4 digits so that we can have really a exact value as we simplify. So what that would be 0.6666. Okay. So inverse sine, you would have theta is equal to the inverse sine times 0.66666. Okay. So that would give you therefore an equivalent of 41.81. So that would be the measure of angle theta. Okay? So, to solve for the measure of our angle y or the measure of angle b, if this one is 41.81, okay, So these are two complementary angles. You can apply that one directly by complementary angles. Measure of angle O plus measure of angle V is equal to 90 degrees. But we will not use this one because we do not know if it is really correct. So to make sure that it is correct, let us just make use what are the given. So that's why to find the measure of angle Y, we'll be using cosine. In such a way, you would have, for letter C, solve for measure of angle V or Y. Okay, once again, we have here solve for the measure of angle B or angle Y. We'll be using ka, not ko. Okay, so cosine is equal to adjacent over hypotenuse. So to solve for that one, cosine y is equal to our adjacent, which is 6 over our hypotenuse, which is 9. So to simplify, you would have cosine y is equal to, what is 6 divided by 9? So that is 0.6666. So inverse cosine, you would have inverse cosine times 0.6666. You would have therefore an equivalent of 48.19. So y therefore is equal to 48.19. So if you're going to combine these two, 41.81, the measure of angle theta and angle y, you would have an exact value of 90 degrees. 41.81 plus 48.19, you would have a measure of 90 degrees because they are complementary angles. Is that clear now? Let's have number 3. Still on the screen. Okay, let us now proceed with our problem number 3. This is very easy question since our triangle here has a length or side lengths, or the legs are 3, this one, and also 3. So meaning they are congruent. If these two legs are congruent, meaning to say our angle opposite to these two legs would gonna be congruent. Remember, this is a right angle, so 90 degrees in measure. So these two are congruent and they are complementary. So what's the measure of this angle therefore? So divide lang. You would have 90 divided by 2. So this would gonna be 45, but we want to show it in a solution. So let's find first the value of our x in this problem. So remember, this would be our hypotenuse, so we'll just use the Pythagorean Theorem. So to solve for x, let's say, solve for x, you can directly have the answer. Okay, let's find it out here in our solution. So you would have x squared is equal to 3 square plus 3 square. So what is 3 square? That's 9 plus 9. So what is 9 plus 9? That will be 18. So x squared is equal to 18. So take the square root of that one. So you would have x is equal to 9 times 2. Factor that one out. That would come, simplify. So that would be 3 square root of 2. So in that way, if this would gonna be the problem, you will just simply add square root of 2. Since this is a special triangle. Okay? So is there any question for this? So that would be x is equal to 3 square root of 2. So we're just simply adding square root of 2, whatever would be the value of our leg. Okay, so let's solve for the measure of angle theta. So still, that is very easy. So to solve for measure of angle theta, so you will be using these two given. So theta is opposite over adjacent. So you can use TOA or tangent. So use TOA. Okay? So for TOA, you would have tangent theta is equal to opposite over adjacent. So our opposite here is 3 over 3. So that is tangent theta. So theta therefore is equal to the inverse tangent. What is 3 divided by 3? That is 1. So tangent, inverse tangent of 1, that would give you how much? 45. So theta is equal to 45 degrees. Same with if you're going to find the measure of angle y. So you would have still tangent. Okay, so TOA, so opposite over adjacent. So still you will have 45 degrees in measure. Is that clear? So again, this is 45 degrees. This would also be 45 degrees, and this one is 3 square root of 2. Since this triangle is a special triangle. Are there questions? Okay, there you go. Let's proceed to number 4. What is in number 4? Oh, it's a problem solving. Okay, let's find it out on the screen. Okay, let's now proceed with this problem solving. Number 4. So our problem here states that a ladder is placed against a wall such that it reaches the top of the wall of the height 6 meter, and the ladder is inclined at an angle of 60 degrees. And we are asked to find how far the ladder is from the foot of the wall. So, in this problem, you're going to illustrate first the problem. So, if this would gonna be the ladder, let's say this would be how the ladder looks like, and this would be our wall. Okay, the wall. And that would be. So, it says here that the ladder is placed against a wall which is 6 meters high. So this would be 6 meter, and this would be inclined. The ladder is inclined at 60 degrees. So meaning this would be 60 degrees in measure, and we're looking for how far the ladder, this ladder, is from the foot of the wall. So we're looking for that length. So starting from here to there. So that is what we're looking for. Okay. So this would gonna be very easy since it has 60 degrees and 6 meter, and this would be the unknown. So to find that one out, you will be using sine, cosine, or tangent. So in this case, we will be using tangent. So to solve for that one, solve for x. Okay, so use TOA. Okay, so to use tangent, you would have tangent 60 degrees is equal to opposite, which is 6 over, which is what is adjacent, that is our x. So to solve for x, therefore you would have cross multiplication. So this would gonna be over 1. So x tangent 60 degrees is equal to 6. So divide both sides by tangent 60 degrees. Okay, so what is left in this side is x. So you would have 6 over tangent 60 degrees. What is tangent 60 degrees? That would gonna be equivalent of 6 over 1.7321. Again, we'll be using 4 digits. Okay, so divide 6 divided by 1.7321, you would have therefore x is equal to 3.46, and that would gonna be in meters. So that would gonna be the distance from this foot of our ladder to the foot of our wall. That is 3.46 meters. Is that clear? Okay, let's proceed to number 5. Okay, next up, we have number 5. A ramp has an angle of inclination of 25 degrees. It has a vertical height of 2.3 meters. What is the length of the ramp in meters? So, once again, we're going to illustrate our problem. So, if this is gonna be the ramp, if you could still remember, our ramp is inclined to with an angle of 25 degrees. So it has 25 degrees here, and it has a vertical height. So this is gonna be the height that we're talking to, which is 2.3 meters. And the question here is, what is the length of the ramp in meters? So from there, that's the vertical one, horizontal rather. So this is what we are looking for. So what is the length of the ramp in meters? So just like when you're going to carry a heavy object from here to there, that would be one way of carrying a heavy object using the ramp. So in this case, you will be looking for our x. So we could use, so hypotenuse is this one. This is gonna be a right angle. So this is gonna be the hypotenuse. This would be the angle and the side length. Okay, so we can use so in this case. So which means sine is equal to opposite over hypotenuse. So sine 25 degrees is equal to opposite of 25, that is 2.3 meters over x. So cross multiply, you would have x sine 25 degrees is equal to 2.3. So divide both sides by sine 25 degrees. Okay, 25 degrees. So you would have x is equal to, what is 2.3 divided by 2 sine 25? What is sine 25 here? This is 2.3, so this would be 0.4226. So divide. As we divide, this would be 5.4425, or you could have 5.44 meters. So that would be the length of our ramp. So in here, this is 5.44 meters. So again, our ramp is inclined at 25 degrees and a height of 2.3 meters. And the ramp therefore is 5.44 meters as we use sine or so. Sine theta is equal to opposite over hypotenuse. Are there questions? Alright, so if there is none, let's proceed. Okay, let's now have the game. With the direction, use the given figure to solve the remaining parts of right triangle air. So we have here. Now, in this case, I'll be giving you only 5 seconds to answer. Alright? So let's start with problem number 1. Okay, side A is equal to 17 and side I is equal to 25. 5 seconds starts now. The correct answer is, we have on the screen. Let's proceed to problem number 2. I is equal to 15 and R is equal to 9. 5 seconds starts now. And the correct answer is, we have on the screen. Congratulations. Now let's proceed to number 3. A is equal to 10 and angle R is equal to 50 degrees. 5 seconds. Go. And the correct answer is on the screen. You have it there. Congratulations. Let's proceed to problem number 4. R is equal to 13 and angle R is equal to 37 degrees. Ready? Go. And the correct answer is on the screen. There you go. Let's proceed to problem number 5. I is equal to 20 and angle A is equal to 66 degrees. Start. And the correct answer is, we have on the screen. Congratulations! Well done! Now let's proceed to the next activity. Still, you'll be using the illustration or the figure here on the right, with the expression that gives the required unknown value. Actually, there are 10 questions. Okay? So, still, I will be giving you 5 seconds to answer. So, let's start with number 1. Okay, number 1. If angle W is equal to 17 degrees and side E is equal to 35, find side W. Go! The correct answer is, we have 10.23. Okay, now let's proceed to problem number 2. If angle W is equal to 67 degrees and side W is equal to 23, find side N. Go! The correct answer is, we have 9.76. You got it. Okay, next, number 3. If angle W is equal to 53 degrees and side W is 10, find side E. This one. Ready? Go! The correct answer is, we have 12.52. You've got it right. Next number 4. Oops, wait a minute. We'll have first number 4. If W or side W is equal to 17.5 and angle W is 61 degrees, find N. Including number 5, if the side W is equal to 23 and angle N is equal to 18 degrees, find side E. So I'll be giving you 10 seconds. Ready? Go! Okay, the answers are, we have 9.70 for number 4 and 24.18 for number 5. Congratulations! Now let's proceed to number 6. If side E is equal to 15 and side W is equal to 8, find side N. Go! And the correct answer is, we have 12.69. Okay, let's proceed to number 7. If side N is equal to 10 and E or side E is equal to 25, find side W. Ready? Go! The correct answer is, we have 22.91. Alright, let's proceed to number 8. If angle W is equal to 19 degrees and side W is equal to 19, find side E. Okay, go! And the correct answer is, we have 6.19. Congratulations! We have 2 remaining questions. There you go. Number 9. If side W is equal to 7 and side N is equal to 13, find measure of angle W. Go! And the correct answer is, we have 28.30 degrees. Alright, now let's proceed to the last question. If side W is equal to 13 and side E is equal to 22, find the measure of angle N. Ready, go! The correct answer is we have 53.78 degrees. Congratulations! Okay, so you have done so well in our activity. So let's now have this part. Self-check questions. Let us now try to be remembered with this question. How did you find the answers? It's gonna be yours. Well, of course, based from our solutions, from our explanation a while back, you could really find how did we answer. What mathematics concepts you have learned in the activity? And do you think you can apply these concepts in your daily life? How? Why? Now let us now proceed with the post test. With the directions, you're going to choose the letter that you think best answers to each of the following questions. Again, I'll be giving you 5 seconds to answer the question. Okay? Then I will reveal the correct answer afterwards. Alright, let's start with number 1. What is the value of x in the figure? Ready? Start. And the correct answer is letter C. Next up, let's proceed to number 2. Find the value of side y to the nearest unit. Ready? Go! The correct answer is we have letter C. Congratulations! Let's proceed to problem number 3. Given the figure on the right, which of the following statement is correct? Ready? Go! And the correct answer is letter D. Okay, number 4. In the triangle COB, what is the length of CO? Ready? Go! And the correct answer is we have letter C, 6.34 inches. Next up, let's proceed to problem number 5. In the triangle BID, what is the measure of angle V to the nearest degree? Ready? Go! And the correct answer is letter A, 65 degrees. Congratulations! Next up, we have number 6. You see Mr. Gomez flying a kite in the park. The kite string is 55 meters long. What angle does the string need to form with the ground so that the kite is 35 meters off of the ground? Ready? Go! And the correct answer is we have letter A, 40 degrees. Congratulations. Number 7. You are designing a ramp. Here in the horizontal distance is thrice the vertical rise. What will be the ramp angle to the nearest degree? Ready? Go! And the correct answer is letter B, 18 degrees. Congratulations. Number 8. An airplane climbs at an angle of 20 degrees with the ground. Find the ground distance the plane travels as it moves 3,000 meters through the air. Give your answers to the nearest 100 meters. Ready? Go! And the correct answer is letter D. That's correct. You have 2,800 meters. Next up, we have number 9. A ladder leaned against a brick wall. The foot of the ladder is 10 feet from the wall. The ladder reaches a height of 18 feet on the wall. Find to the nearest degree the angle that makes with the wall. Ready, go! And the correct answer is letter D, 29 degrees. Congratulations. Lastly, we have number 10. A 67 feet wire connects a point on the ground to the top of a pool. The cable makes an angle of 55 degrees with the ground. What is the height of the pool to the nearest foot? Ready? Go! And the correct answer is we have letter B, 55 feet. Congratulations. Okay, so thank you very much for listening, and I hope that you're able to get the best knowledge that you need in your lesson. So once again, this is quarter 4, week 2, module 2, solving right triangles using trigonometric ratios. Once again, thank you so much for watching. God bless and stay safe.
I'ma cook it up like this.